Okay, we're just going to continue on with this drawing and try and get finished off fairly quickly if we can. What we need to do is draw in our intersection between the cylinder, which is, there's the top of the cylinder there with the cone sitting on top of it, with that sloped surface there, and there's that sloped surface there. That's that edge. Okay, so we can see, looking in on the end view, exactly where every point, where it cuts it. So what we do is we divide up our plan into our 30s and 60s, and we get our points from 0 to 6. So I've already carried 6 up, so just let me or 0 and 6 up. So I'm just going to do that so you can see it again. So here is 0. 0 comes across to my 45-degree line, and I have 6 and 0, because when I'm looking in that way, I see 6 first and then 0. Then it goes up, and it goes up to this point here. Okay, that's where it cuts it there. Now at this point it runs across, and there is, as I'm looking in this way, that's going to be 6 and 0, because there's the sloped surface that the cylinder is running down into, and there is 0, carrying 0 up, and there is 6, carrying it up. Okay, now let's have a look at, as I'm looking in this way, let's have a look at 5 and 1, and let's do this one in red. So 5 and 1 runs across there like that. I have 5 and 1. It hits the 45-degree line, and then we bounce it upwards, and there is where 5 and 1 cut that sloped surface. That sloped surface is now just a line. You're looking right in at the edge of it there, and that gives me 5 and 1 there. Now I'm looking in this way, so I see 5 first and 1 is behind it. Now what I can do is I can bring 5 and 1 across, and it runs across that way. Okay, how far does it run across? Well, we know it's somewhere in between there, so if I bring up 1, and that gives me the point there, and that there is 1, and if I bring up 5, and that brings me to the point there, and that one there is 5. I have 5 to 6, and there's those points located. Now the last one I need to do is 4 and 2. So 2 is directly behind 4, so I carry that line across. So there's 4 and 2. Draw in my arrow. Carry my line upwards. Cuts the surface there. So there is 4 and 2. Carry line across. There is 2, so bring 2 vertically up. Now there's 2 gone that way. It comes across, that's point 2 in there. Now where's 4? 4 comes up vertically here, comes across there, and 4 is here. Okay, so I have 6, 5, 4, 3, 2, 1, 0. So now I'm gonna draw in my ellipse lightly, trying to get an even curve. Do it lightly, and then you can heavy it in afterwards. So now what we have here is where the cylinder intersects and cuts, the line where it cuts into that slope surface. Now, it's quite a lot in this drawing. It can be a bit confusing, but you need to work it line by line. You need to identify surfaces in sides and surfaces in one view and see what they look like in the other view. For example, here is S in elevation. In plan, this is S. It's just a line, okay, because you're looking straight down on top of it. But when I look in my end view, I see that much of S. So here is S in end view. Now look, that's not the same as that, but it's because you're looking at it in different views. You see it from in different directions, and S is wider there than it is there. So again, here's S. S appears as an edge in plan, right? So when you look in that way, you see that much of S, and there is S there. If I wanted to pick, let's just say we'll pick another surface. So let's look at, we'll call this X. This surface here and here, that's the surface that the cylinder runs down into. X is here and here. In plan, it's here. And in elevation, in end view, when I look in this way and look across that way, that's X. That line from there to there, the whole lot of that's X, the whole lot of that surface turns into a line because you're looking straight in at the edge of it, and that enables us to see exactly where the line cuts the cylinder. Now, one other thing, you're asking this question, and I haven't done it yet, but I'm going to show you because I have a bit of space to do it, and it pretty much is based on what we're talking about there. What we need to do is find a true shape, right? Now, the true shape of a surface is when you look directly in at it. Now, maybe before, you might have been used to taking an auxiliary view. So if you're going to take an auxiliary view from something, you need to go and find that surface as an edge view. So here is S, and here is S here. Now that's an edge view of S. Okay? So if that's an edge view of S, that means if I look straight in there, somewhere up here I could draw an auxiliary view, and I could draw the true shape of S. And that'd be fine. But another way we have of doing this is by using what's called a rebatment. And a rebatment is when you take a surface and you just spin it around so that it's facing the way we want to see it, so that we can see exactly what the true shape of it is. So I'm looking down on top of the surface S here. So if I put my compass here, I'm just going to spin S. I'm just going to take it and I'm going to spin it around there. And what that does is it takes it and it flaps it back out. Where is it now? That there has gone to here. Now where is it? It's in a position that we can look straight in at the front of it. It's parallel to the XY line, which means it's parallel to the plane that we're projecting onto. So what that means is we can carry that surface up here and carry our points across, and we've spun them all out. Okay, so we swung that around there, put the point of our compass there, swung it around to here, then we brought it up into elevation. Now all those points go straight out, they all go straight out there like that, and what we get is, oh sorry, I'm missing a point. I didn't swing this point here that sits in the ground, which is there. I need to spin that one around there as well. So if I spin that around to there, and carry that up to there because that's as far as it goes, sitting on the ground. What I get is, I'm going to just draw it in red so we can see it. Just spun onto the side of the drawing like that. That's what's called the true shape of S, and it's done by rebatment. And rebatment is when you spin something around to make it parallel. So we can parallel to the plane that we're projected on, and the plane in this case is the area above the XY line, which is called the horizontal plane, or HP. Sorry, it's just called the vertical plane. Down here is called the horizontal plane. Okay, so what we have here is the true shape of S. Okay, we took it, we spun it around. Now we could only spin it around because it appeared as an edge in this view. We couldn't have done that anywhere else. So we spun it around so that it was parallel to our XY line. Now if we look straight in the front, we can draw exactly the exact true shape of it in elevation. Alright, so that's that question complete. Part A. Draw our elevation in the direction of arrow A. That's a dotted line there at the back of it. Part B. Project a plan from the elevation. Here's B. Part C. Project an end view in direction of arrow B, and that's that way there. And part D. Determine or show the true shape of S. And we did that by what's called rebatment, by spinning it around so that it's parallel to where we're drawing onto. In this case it's the vertical plane, carrying our points across, and that gives us the true shape of S. Okay.